tables are common ways of presenting functions. Consider Table 2.1, which shows population data from the United States Census Bureau. Does the table above represent a function? If so, what are the independent and dependent variables? Notice from the table that population depends on the year. So, population is a function of the year. Because population is doing the depending, population is the dependent variable, and years is the independent variable. Data tables are meant to convey information, but the tables themselves are sometimes dry and difficult to decipher. One tool that helps us understand quantitative data is the bar graph. To the left is a bar graph of the census data in Table 2.1. This graph gives us a better picture of how the population increased with time. Even so, the apparent regularity of the graph hides some important information. We'll dive into this a little bit deeper after we talk about percentage change. Definition. The percentage change, which is sometimes called the relative change, in a function value is equal to the change in function value divided by the previous function value. Recall that function value is another word for the dependent variable value. Example 4. Suppose the function value changes from 4 to 5. Find the percentage change. First, we will need to find the change in the function value, which is also called the absolute change in the function value. Since our function value is increasing from 4 to 5, the change, or absolute change, in function value is equal to 5 minus 4, or 1. We need to divide the change in function value by the previous function value. Since 4 occurred before 5, the previous function value is 4. Since the percentage change is the change in function value divided by the previous function value, our percentage change is 1 divided by 4, or 0.25, or 25%. In practical terms, this means that 5 is 25% more than 4. Part B. Suppose the function changes from 5 to 4. Find the percentage change. Notice this is similar to Part A, but instead of going from 4 to 5, we are going from 5 to 4. First, we will need to find the change or absolute change in function value. In Part A, we took 5 minus 4 and got 1. In Part B, we'll take 4 minus 5 to get negative 1. Note the negative sign here is used to represent the fact that we are decreasing in function value. Next, just as we did up here, we will note the previous function value. Our previous function value for Part B is 5. Finally, recall that our formula says to find the change in function value and divide that by the previous function value. Negative 1 divided by 5 equals negative 0.2, or negative 20%. It may be surprising that the percentage change is different, even though the function values are the same, but in the reverse order. Note that the reason negative 20% makes sense for the percentage change in Part B is that 4 is 20% less than 5. That is, if you divide 5 up into 100 parts and get rid of 20 of those parts, you will have 4. On the other hand, if you divide 4 up into 100 parts, you will have to add 25 of those parts to 4 in order to get to 5.